Hi everyone! In this exercise, we will look into some of the methods that we can use for processing or pre-processing SAR images for the detection of water bodies or any other object. First, we add a geometry around our area of interest, and then we will center it to the map. After, we will import Sentinel-1 collection using these filters, which we used in previous exercise. Next, we will select single image from the collection using EE.image and add filter.sort to sort it by start time, and add .first so that it will give us the first image from the filtered collection, and add it to the map. Hit run. Now that we have our image, let's calculate some statistics on it. First, we will calculate standard deviation for one image over pixels using reduce neighborhood method. It applies on single band as well. We will add .reduce neighborhood function, and in its additional arguments, we will add the reducer we want to apply, which is standard deviation, and then we will decide the kernel size, like 5. It is the same method which we did while calculating median from a collection in our previous module. Print it into the console and add it to the map by running the script. Here we go, SAR image with standard deviation. We can see the area where there is more variation or brightness. There are water bodies, so it means this kind of reduction is useful to extract and visualize specific objects. On the other hand, if we use a reducer, which is mean, which can be calculated using the same method, we can see the image is more blurry, which means compared to our original image, this blurred image has a more generalization effect. This kind of reduction is used to classify image to avoid more small and small pixels.
Now, let us create a boxcar rectangle kernel, both on VV and VH bands. Before this, I want to show you guys how to convert Sentinel-1 image from power to decibel, and vice versa, as sometimes in processing SAR images, it is required. For this, I have created two functions. One will convert image to power, and other will convert it to decibels. You can use any one according to your need. Introduce a function with the name toPowerImage and add arguments like return ee.image, to power divided by 10, and to convert it into decibels, return the image with log of 10 and multiply it by 10. Here we have created two functions. Let us use them both to define a boxcar kernel. Introduce two variables for both bands and add function 2dB, and in brackets add toPower. It will convert the image from decibels to power by running this function. Now, pass the arguments to define kernel using EE.reduce neighborhood. I will go with the reducer mean and then define the kernel size to 3 by 3. Add both bands to the map by adding them and then hit run. Here, we have a blurry image with the boxcar kernel. This defines that the urban areas have radiative colors. So now we can see that in our image there is a lot of that different seen on the ground. So this noise has to be eliminated before we apply our classification. For this, we have to refine it by using a special function we call refinedLi. Simply copy all of this section. It is the function we have created to refine the image. Convert your power image to decibel and add refinedLi function to it, like this, for both bands. Select first image from the collection and then add them to the map and hit run. Here you go, a refined image. Thanks for watching.